Hello everyone, welcome to CHEM9. Today we will learn about atomic structure and radioisotopes. In this chapter, we'll first learn about the elements, what are elements, and we'll also discuss about structure of the atom. Then we'll talk about what is periodic table, how elements are arranged in the periodic table, and we will also discuss what are periodic properties, by which I mean is how properties of elements vary within the periodic table. And then we'll discuss about how electrons are arranged in an atom. So we'll talk about electron arrangement and what are valence electrons. And in the second half of this chapter, we'll discuss about radioisotopes. We'll talk about what is radioactivity, and in that session we'll learn about what is alpha particle decay and what is beta particle decay. And then we'll discuss about what is high energy electromagnetic radiation, and we'll learn about the penetrating power and biological effects of radiations. In chapter number 1, we learned about matter. Everything around us which occupies space and has mass is called matter, which includes trees, bricks, buildings, air, uh, the entire planet. Everything is matter. Now the question is, what is matter made up of? The simplest answer is matter is made up of tiny small building blocks, and those building blocks are known as atoms. So atoms are the building blocks of matter. Now what are elements? Elements are those kind of matter which consist of only one kind of atom. Elements cannot be broken down into further smaller. Uh, so for example, if you have a pure gold ring, so the pure gold ring, so imagine this is a gold ring. This pure gold ring is made up of tiny building blocks, and these tiny things are gold atoms. Now because this gold ring is made up of only gold atoms, it doesn't have any other kind of atom. Therefore, the gold is element. We'll discuss later on that what are those matter which are made up of more than one atom. Those we will discuss later. Now, next question is, what are atoms, or what are atoms made up of? So atoms are made up of three what we call subatomic particles, and these particles are called protons, neutrons, and electrons. Atoms have a extremely small and dense central part which is called nucleus. Nucleus is in the middle of the atom, and it is made up of protons and neutrons. In this figure, you can see the red squares and the blue spheres. So the red one of them are protons, and the red ones are neutrons, and the blue ones are protons. Around the nucleus, there is a big space. For example, the space shown in that green area, so this entire space. So this entire space holds electrons. Now electron could be anywhere around this space, so there is some empty space as well as electrons. So we call this electron cloud. Electrons are moving rapidly around the nucleus. This table shows the relative mass of subatomic particles, which are protons, neutrons, and electrons. Remember, protons and neutrons both reside inside the nucleus, and protons have a +1 charge and neutrons have 0 charge. Their masses in gram are given, you don't have to remember that. And in AMU scale, AMU stands for atomic mass unit. This is called relative mass, so the value in AMU scale is also given. Again, you don't have to memorize these numbers. Only thing you need to memorize is that the mass of proton and mass of neutron is almost the same, is almost same. And mass of electron is extremely small as compared to protons and neutrons. In fact, electron is more than 1,000 times smaller than protons and neutrons. So we can say that mass of electron is negligible as compared to, so it's extremely smaller than mass of proton or neutron. So as compared to proton and neutron, mass of electron is negligible. Every element has been assigned a 1 or 2 letter atomic symbol. For example, carbon has been assigned a symbol C, nitrogen is N, and chlorine is Cl. Many times the symbol matches with the first letter of the element name, and many times it does not. For example, iron has a symbol of Fe and not I or Ir. And gold, symbol for gold is Au, and as shown here. Now these names or these symbols came from their Latin or Greek name. For example, the Latin name for iron is ferrum and gold is aurum, so that's where Fe and Au came from. One thing to remember here is that when you write the symbol, it's always the first letter will be uppercase. For example, F, the first letter of symbol for iron F is uppercase, and the next one will be lowercase. Chlorine will be C uppercase and L lowercase. Similarly, symbol for calcium is C uppercase and A lowercase. And if you write C and A both uppercase, that would be incorrect. This is a symbol for California, not calcium. An element is defined by the number of protons in its atoms, and number of protons is known as atomic number. Every element has a different atomic number. For example, atomic number for carbon is 6, nitrogen is 7, chlorine is 17, and gold is 79. So from the atomic number, we can also determine how many protons atoms of these elements have in their nucleus. For example, in case of carbon, because atomic number of carbon is 6, therefore carbon has 6 protons. Atomic number of nitrogen is 7, so therefore nitrogen atom has 7 protons. So in other words, atomic number is equals to number of protons in the nucleus. So if you want to determine how many protons gold has, all you need to do is you look at the atomic number of gold. It's 79, therefore gold also has 79 protons. In previous slide, we also learned that nucleus contain neutrons as well, along with the protons. The combined sum of neutrons and protons will give you the mass number. Therefore, we can say, let me clean up, that atomic mass is equals to number of protons plus number of neutrons. So if you know the atomic mass and atomic number of any species, we can calculate the number of neutrons also. For example, gold has atomic mass of 79 and atomic mass of 197 and atomic number of 79. Therefore, the number of protons is equals to Well, if you reshuffle this formula, you will get number of protons is equals to the atomic mass minus atomic number. So if you subtract atomic mass from atomic number in case of gold, the number of neutrons will come out to be 118. So gold has 118 neutrons. Let's fill in these blanks. Dash and dash are located in the nucleus of atom. So we learned that inside the nucleus of atom we have two kind of particles, and these two kind of particles are protons and neutrons. This is our nucleus. Dash have negligible mass. We learned earlier electrons are the species who have negligible mass. Which one has a positive charge? We also learned previously protons have positive charge, and which one has a negative charge. At this problem, calcium atomic number 20. So calcium, it has atomic number equals 20. And we want to find out how many protons and how many electrons are present in neutral atom of calcium. So we learned in previous slide that number of proton is same as atomic number. And because atomic number is 20, therefore calcium has number of protons equals 20. So calcium has 20 protons in its nucleus. Now we want to figure out how many electrons has. Remember, in a neutral atom, number of protons and number of electrons are equal, because that's why they are neutral. Otherwise, protons has positive charge. If electrons are not same as protons, then the charge will not be neutral. Therefore, number of electrons is also 20. So in any neutral atom, protons and electrons will always be the same. Next question is, what is the atomic number for these macronutrient elements? For this, we have to look at the periodic table. We will discuss periodic table in detail, but I'm just gonna write the values here. So phosphorus, if you look at the periodic table, so you will see a periodic table. It will have some boxes, and so periodic table has boxes of elements, and in the box, whatever number is written on top of the box, for example, for phosphorus, the top number is 15 and the bottom number is 30.97. This top number is the atomic number. So atomic number for phosphorus is 15. Similarly, if you look at sulfur, so for sulfur, symbol is S, and the top number is 16 and the bottom number is 32.07. This bottom number is atomic mass. But anyway, we only want to know the atomic number. Therefore, for sulfur, atomic number is 16. Chlorine, atomic number is 17. Although all atoms of a given element have the same number of protons and electrons, they may differ in their number of neutrons. For example, we may have a carbon atom, and in carbon atom inside the nucleus we will always have 6 protons, and around the nucleus we will always have 6 electrons. So that's never gonna change. So 6 protons and 6 electrons. However, the number of neutrons inside the nucleus, that may be anywhere from 6 neutron. In some other carbon atom, the protons still gonna be 6 and electrons still gonna be 6 electron. I'm not gonna draw it, but the neutrons, instead of 6, now it could be 7 neutrons, and in some cases uh, we may have 8 neutrons and 6 protons and 6 electrons. So the point is that in an element, the atoms will have same number of electrons and same number of protons. However, the number of neutrons may differ. So those kind of elements, or those kind of atoms which belong to same element but they differ in the number of neutrons, those are known as isotopes. So all these three examples are isotopes of carbon. Now, what difference will it make? The difference will be in the mass number, atomic mass. So in all these three cases, atomic number will always be equals to 6 because there's a 6 number of protons. However, the atomic mass in the first example, remember atomic mass is equals to number of protons plus number of neutrons. There's 6 plus 6, it will be 12 in this case. Atomic mass in this middle example, this atom, 6 plus 7, it will be 13, and in the last example atomic mass equals 14. So we can say that isotopes are those atoms which have same number of protons but different number of neutrons. You can also say isotopes are those atoms who have same atomic number but different atomic masses. So as I explained earlier, mass number is equals to the number of protons plus number of neutrons. So therefore, if we have three different kind of isotopes, by the way, these numbers are used to refer to what isotope we are uh, referring here. So carbon 12 means it's the isotope of carbon which has the atomic mass equals 12. So in all these isotopes, the atomic number will remain the same, number of protons will remain the same, but the number of neutrons will be different. And because number of neutrons is different, atomic mass will also be different. Most elements have more than one naturally occurring isotope, and sometimes additional isotopes can be prepared artificially. For example, silicon has 3 naturally occurring isotopes and 17 man-made isotopes. In order to identify different isotopes of an element, we use nuclear symbols. The nuclear symbol for an isotope is written with the mass number as a superscript. If this is the symbol for the element X, the superscript which is up here, so here we use the mass number or atomic mass. So atomic mass will go on the superscript on the left hand side of the symbol, and the atomic number will go as a subscript. So here it will be atomic number. So this kind of representation is known as nuclear symbol. An example of nuclear symbol is shown for iodine isotope here. So in this case, the symbol is I, and the atomic number of iodine is 53. So 53 is written as a subscript, and the atomic mass of iodine is 125, which is represented as a superscript. Similarly, if I have an isotope of carbon with atomic number 6 and atomic mass equals 12, so its nuclear symbol will be written as symbol for carbon C, and 12 will be as a superscript and 6 will be as a subscript. So this will be the nuclear symbol for carbon isotope, or similarly you can write nuclear symbol for other isotopes. The nuclear symbols of various isotopes of carbon are uh, shown here. Please remember that this kind of notation is called the nuclear symbol, and some other representations which are also used are shown here. So C12 means uh, carbon isotope with atomic mass 12, similar to C13 or C14, or we can also say carbon 12, carbon 13, or carbon 14. So these are also other representations. Let's complete this table. For this we will need some information from the periodic table. So let's first complete information about barium. So isotope name is barium, mass number. Remember, uh, in this in this representation, uh, the number after the name is the mass number. So therefore, the mass number of this barium isotope is 131. Atomic number. Atomic number. In order to find atomic number, we will need information from periodic table. So if I look at the periodic table, I will see barium has atomic number 56. Number of protons. Number of protons is same as atomic number, so it's 56. And number of neutrons. So remember, mass uh, mass number, which is same as atomic mass, is equals to number of protons plus neutrons. We already know the mass number, which is 131. We already know the number of protons, which is 56. So we can now figure out the number of neutrons. So number of neutrons will be equals to 131 minus 56, and this comes out to be 75. All right, let's complete the next row. In next row, we do not know what is the name of the isotope, but we do know the atomic number. So if I consult the periodic table, and at 80 atomic number, the element at 80 atomic number is mercury. So therefore this element is mercury. And now what kind of mercury? We need to find the mass number, and we know the mass number is equals to number of protons plus number of neutrons. We know the number of protons, we know the number of neutrons, therefore mass number is 80 plus 117. So this comes out to be 792, 297. Let me make sure I'm doing it correctly. Sorry, 197. I apologize. So therefore this particular mercury isotope is mercury 197, and its mass number is 197, and atomic number is 80, and number of protons is also 80. We know that more than one isotope exists for each element. So in that case, if we want to report the information about the atoms of that particular element, what atomic mass shall we report? Because atomic number will not change, so atomic number will remain the same. However, the mass number is different for different isotopes. Do we report the mass number of smaller isotope or the mass number of larger one? What do we do? The answer is that we report the average atomic mass of all the isotopes combined together. However, this average is not the uh, normal average which we calculate for of two numbers. The atomic mass of an element is calculated as a weighted average of all the isotopes of element based on the natural abundance of each isotope. For example, in case of chlorine, uh, two isotopes of chlorine exist. First one is called chlorine 35 and second one is called chlorine 37. In nature, 75% of chlorine atoms belong to chlorine 35 and about 24.24 atoms belong to chlorine 37. So when you want to calculate the weighted average, this is the formula which we use, which is equals to mass of isotope 1 multiplied by fractional abundance. How do we calculate fractional abundance? We just divide the percentage by 100. So let me show you how we apply this formula. So the average atomic mass of chlorine is equals to mass of isotope 1 and mass of isotope 1 is 34.91 multiplied by natural abundance, but in fractional natural abundance. How do we calculate fractional abundance? You take the percentage was 75.76 and you divide by 100 plus then the second isotope atomic mass for second isotope was 36.97 multiplied by fractional abundance, so percentage divided by 100. So this comes out to be 34.91 multiplied by 0.7576 plus 36.97 multiplied by 0.2424, and if you solve this you will get 35.45 AMU. AMU stands for atomic mass units, and that's how we calculate the average atomic mass. Let's take a look at another example. Calcium has four naturally occurring isotopes. These are calcium 40, calcium 42, calcium 43, and calcium 44. First question is, which isotope is the most abundant on Earth? Most abundant means percentage wise which one has the highest percentage. So we can clearly see that highest percentage belongs to calcium 40. So the answer is calcium 40. Second question is, which isotope has the greatest number of neutrons? Greatest number of neutrons in an isotope is from that isotope which has highest number or largest number of atomic mass. So the correct answer is calcium 44. You can calculate the number of protons. If you do, you will see this one has 24 neutrons. The others will have less than that. Last is, what is the atomic mass of calcium? How is this calculated? What it's asking you to do is calculate the average atomic mass. So average atomic mass we learned in previous slide is equals to the mass of isotope 1, which is 40, multiplied by fractional abundance, which is 96.95 divided by 100, plus mass of second isotope, which is 42, multiplied by fractional abundance, plus the third isotope 43 multiplied by 0.19 divided by 100, and then plus the final, which is 44 multiplied by 2.09 divided by 100. If I solve this, I'll get, let me write it here. So it will come out to be 40 multiplied by 0.9695 plus 42 multiplied by 0.0076, 43 multiplied by 0.0019, 44 multiplied by 0.0209. And if I solve this, the answer will come out to be 40.1005.